All right, so today we're going to dive into some pretty cutting-edge AI research.
So good.
This paper's called Multimodal Latent Language Modeling with Next Token Diffusion.
Hmm.
It's a bit of a mouthful,
Yeah, a little bit.
but the idea is actually pretty cool.
Oh, for sure, yeah.
Essentially, the researchers came up with this model they're calling LatentLM,
Okay.
and it's all about helping AI understand and work with different types of data.
Interesting.
Not just text,
Right.
but images,
Okay.
audio, you name it, in a much smoother and efficient way.
So making it more like how we experience the world.
Exactly. That's a great way to put it.
Like when we watch a video, we're taking in the visuals, we're hearing the sounds, maybe even reading subtitles, all at the same time.
Yeah.
Latent LM is kind of aiming to give AI that same ability.
Okay, so instead of having like separate AI systems for different tasks,
Right.
like one for understanding text, another for recognizing images, and so on,
Yeah, those kind of specialized AIs.
it's trying to create this more unified system that can handle it all.
It's like the difference between having to call in different contractors for every little repair around the house,
Oh, I like that analogy.
instead of having one handy person who can just handle it all.
Yeah, that's a great way to think about it.
And that's where latent LM comes in. It's designed to be more like that all-in-one handyman.
Okay, so how does it actually work? The paper talks about these things called latent vectors.
Right.
What are those in plain English?
Well, you can think of them as a kind of universal code that latent LM uses to represent any type of data,
Mm,
whether it's a sentence, a picture, or a sound clip.
right.
It all gets converted into this special code,
Okay.
this code that the model can understand.
So it's kind of like translating everything into a single language.
Yeah, exactly, that the AI can speak.
And that allows it to process everything much more efficiently.
Precisely. It's about handling all these different types of data within the same framework,
Yeah.
which makes it much faster, more efficient.
So it's not just about understanding multiple types of data, but doing it in a super streamlined way.
Exactly. And that efficiency opens up some really interesting possibilities.
Okay, like what?
Well, for example, the paper talks about how latent LM could be used to speed up text-to-speech synthesis,
Oh, wow.
meaning we could have AI that can generate realistic sounding speech almost instantaneously.
Now that would be a game changer.
Right. Imagine the possibilities for things like virtual assistants,
Uh-huh.
audiobooks, or even real-time language translation.
I mean, that would be incredible.
Absolutely. And it goes way beyond just text-to-speech.
Okay.
The researchers also showed that latent LM is really good at image generation.
I saw that. The images in the paper were pretty impressive.
Yeah, especially when it comes to creating high-resolution images with a lot of detail.
It's clear that this technology has the potential to create some truly stunning visuals.
And it's not just limited to static images either.
Oh, really?
The paper even suggests that it could be used to create realistic videos and interactive simulations.
So we're talking about AI that could potentially create entire virtual world.
It's pretty mind-blowing.
It is.
Right. This ability to blend different modalities like text, images, and maybe even video opens up a whole new frontier for AI applications.
Okay, so we've got this incredibly versatile and efficient model that can handle all sorts of data.
Yeah, we do.
But how does it actually work under the hood?
Well, that's where things get a little technical.
I'm sure you can explain it.
I'll try my best. One of the key innovations in latent LMM is something called next token diffusion.
Next token diffusion.
No.
What is that?
Okay, so imagine you're building a puzzle,
Mm.
but instead of putting all the pieces together at once, you're adding them one by one. You're gradually revealing the complete picture.
Okay, I can see that.
And that's kind of how it works with latent LM.
So those latent vectors, those universal codes, they're generated piece by piece using this next token diffusion process.
Exactly. Like the model is gradually adding details to a sketch, refining it step by step until it gets to the final representation of the data.
So this gradual approach, that's what makes latent LM so efficient.
Yeah, exactly. By generating the latent vectors piece by piece,
Right.
the model can avoid some of those computational bottlenecks
Okay.
that you get with other approaches.
Which makes the whole process much faster.
Faster, yeah.
Makes sense, but why is it more efficient to do it piece by piece?
Well, that's a great question.
It seems counterintuitive.
It does. It seems like it would take longer.
Yeah.
But the key is in how next token diffusion uses prediction.
Prediction. How does that play into it?
Think about it this way. If you already have a few pieces of a puzzle in place,
Right.
it's much easier to predict where the rest should go.
Yeah, you start to see the bigger picture.
Exactly. And that's what latent LM is doing with next token diffusion.
Hmm.
It's using the information from the parts of the latent vector that have already been generated
Right.
to predict what the next piece should be. So it's a much more efficient process than trying to generate the whole thing from scratch.
So the model is kind of learning from its own progress, refining its predictions as it goes along.
Precisely.
Yay.
And this ability to predict and refine, that's what allows LatentLM to get such impressive results.
With much less effort, basically.
With significantly fewer computational resources.
This is all starting to make sense, but there's one more piece of this puzzle I'm curious about.
Okay, what's that?
The paper mentions something called VAE.
Right.
What is that?
Yes, VAE. That's another crucial ingredient.
Okay.
It's a special type of variational autoencoder, or VAE, and it plays a really important role in making sure the model is accurate and robust.
So we're getting into the nitty-gritty now.
Yeah, we're getting into the secret sauce.
All right, well, before we dive into VAE,
Oh.
I think we should take a quick break and give our listeners a chance to catch their breath.
Sounds good.
We've covered a lot of ground already.
We have.
And there's a lot more to come.
I'm looking forward to it.
Me too.
Okay. All right, so where were we?
Yeah, right before the break, we were about to dive into the specifics of FAW.
Oh, yeah? FAE.
Sounds like a pretty important piece of the puzzle.
It really is.
Okay.
Traditional VAEs, while they're powerful,
Yeah.
they can sometimes fall short.
In what way?
Well, when it comes to capturing, the full richness and diversity of the data
Okay.
that they're trying to represent.
Like trying to fit a whole orchestra into a phone booth.
Oh, I like that.
You just can't get all those instruments and sounds in there
Right. You're going to lose something important.
without losing something, yeah.
Yeah, and that's where FAE comes in.
Okay.
It's specifically designed to prevent something called variance collapse.
Variance collapse.
Yeah, which is essentially, when the model oversimplifies things and loses those crucial details.
So it's like CAE is the conductor of the orchestra,
I like that.
making sure all the instruments have their space to shine
Yeah.
and contribute to the overall symphony.
Yeah, that's a great way to put it.
Okay, but why is that so important?
Well, think about it this way. If you're using LatentLM to generate something, like, say, a new image or a piece of music, you want it to be creative. Yeah.
Of course, yeah. Nobody wants AI that just spits out the same old boring stuff.
Exactly. You want something original.
Right.
And that's where VAE really shines,
Okay.
by preventing that variance collapse. It makes sure that the model has a wider range of possibilities.
So it can create more interesting outputs.
More diverse, more interesting, and ultimately more useful.
So VAE is kind of like the secret ingredient that gives LatentLM that extra creative spark.
You could say that, yeah. It helps it move beyond just mimicking existing data into generating something truly new.
Now that's exciting.
Right.
But the paper hints at some even more mind-blowing applications for LatentLM
Oh, yeah.
beyond just image generation and text-to-speech.
Absolutely, like latent multimodal reasoning.
Latent multimodal reasoning.
Yeah, it sounds a little scary.
It does? What does that even mean?
Well, it's all about taking that ability to understand different types of data, right? And then going a step further,
Okay.
enabling the AI to actually reason about that data.
In a more complex way.
Yeah, in a more complex and abstract way.
So it's not just about recognizing objects in an image
No.
or understanding words in a sentence.
It's about making connections between those different pieces of information.
And drawing conclusions.
Yeah, like imagine an AI that can not only see a picture of a busy street,
Right.
but it can also understand,
What's going on?
the social dynamics, the potential risks, even predict what might happen next.
That's pretty wild.
Yeah.
So what kind of real-world applications could we see from something like that?
Well, I mean, the possibilities are huge.
Yeah.
Think about self-driving cars that can navigate traffic like a human, or AI assistants that can actually understand our needs and give us personalized recommendations.
It actually gets us.
Exactly. It's like giving AI common sense.
Yeah.
That ability to connect the dots
Right.
that we humans take for granted.
I mean, that's the goal. Right.
It is.
Yeah.
And LatentLM, with its ability to blend these different modalities, provides a really strong foundation for that kind of reasoning.
Wow. Okay, so we've got latent multimodal reasoning.
Yeah.
The paper also mentions things like video generation
Right.
and world modeling.
Those are exciting too.
Yeah, what about video generation?
Well, video generation, as you might imagine,
Yeah.
it's a natural extension of image generation.
Right, but it seems like it would be a lot more challenging.
It is. It is much more challenging.
Because you have to consider time, right?
Exactly. It's not just the images themselves,
Yeah.
but how they change over time.
Like animating a flip book.
Oh, that's a great
You
analogy.
need to get the drawings right, but you also need to string them together in the right way.
To make it look smooth.
Yeah.
And that's where LatentLM's sequential nature comes in.
Okay.
Remember, it processes the information piece by piece, which makes it perfect for handling those temporal aspects of video.
So are we talking about LatentLM creating entire movies someday?
I mean, it's possible, but I think we're still in the early stages.
Yeah.
But the researchers think it could be really useful for generating, short, high-quality videos or animations.
Where that smooth flow is essential.
Exactly.
That's still pretty impressive.
It is. It is.
Okay, what about world modeling?
So world modeling,
What is that?
it's basically about creating these virtual environments.
Like simulations.
Yeah, simulated worlds, basically,
Yep.
that can be used to train AI systems.
It's like building a giant sandbox for AI.
Yeah, that's a great way to think about it.
So they can learn and experiment
Exactly.
without any real-world consequences.
And these simulated worlds can be really detailed, really realistic.
That's going to be super useful for things that are too dangerous or expensive to do in the real world.
Absolutely. Like self-driving cars.
Right.
Or robots that, do surgery.
Oh, wow.
And that's where LatentLM could be really valuable.
Okay, how so?
Well, because it can handle both visual data and language data.
Yeah.
It could be used to create these world models that are not only visually stunning,
Right.
but also more interactive.
Interactive in what way?
Well, they can respond to language instructions.
So, like, you could tell the AI, build me a house on top of that mountain.
Yeah,
And
exactly.
it would actually do it.
That's the idea.
That's pretty amazing.
Right. And this ability to blend language and visual information
Yeah.
could be really powerful for training AI that needs to interact with the real world
Okay.
in a more intelligent way.
It's like teaching AI to understand not just what we see, but also what we mean.
Exactly, precisely.
Okay, so this is all pretty mind-blowing stuff.
It is.
It's amazing to think that one model could have such a big impact.
I know. It's really a testament to this idea of a more unified approach to AI,
Yeah.
breaking down those walls between different types of data.
Makes sense, but are there any downsides or risks with this technology?
Well, that's a good question.
Could something like LatentLM be misused?
I mean, it's possible, right? Like with any powerful technology,
Yeah.
there are always risks.
Right.
But it's important to remember that LatentLM itself is just a tool, a very sophisticated tool,
Right.
but a tool nonetheless.
It all comes down to how we use it.
Exactly. How it's used and what
Yeah.
impact it has
Yeah.
ultimately depends on the people who are developing and deploying it.
So it's like, giving someone a hammer.
Right.
You can use it to build a house.
Yeah.
Or you can use it to break a window.
It's not inherently good or bad.
Right. It depends on the person using it.
Exactly. Which highlights the importance of ethics in AI.
Oh, for sure. We need to be thinking about the potential impacts of this technology
Yeah.
and make sure it's being used responsibly.
Responsibly and for the benefit of humanity.
I think that's a great point to end on.
Yeah.
We've explored the ins and outs of LatentLM,
yeah.
from next token diffusion to CAE.
To all the potential applications.
Yeah, and it's clear that this is a big step forward for AI.
It really is.
So thanks for joining us on this deep dive.
It's been a pleasure.
And we'll be back next time with another fascinating topic from the world of cutting-edge research.
I'm looking forward to it.
Me too.
All right.
Welcome back. We've been talking all about LatentLM, this new AI model, and I'm really starting to see why people are so excited about it.
It's definitely groundbreaking. One of the things I find so interesting is how elegant it is. It's complex, but the ideas are actually pretty intuitive.
Yeah, I agree. Like that idea of next token diffusion, building those vectors piece by piece, just makes sense. Like,
it's natural, right?
yeah, like you were saying before, traditional VAEs can struggle to capture all the nuances.
Right.
Like trying to cram a whole library into one book, you lose so much.
Exactly. You lose something important.
Yeah.
But next token diffusion is different.
How so?
Well, it's like having this magic book,
Okay.
that can expand to hold everything.
So it embraces complexity.
It does. It captures those details that make data truly meaningful.
And that has to affect the results.
It does, big time. We're talking about AI that can create, truly novel things we might not even imagine.
That's a pretty exciting thought.
It is. Where could this lead in a few years?
Right. I mean, we're already seeing it used for images, text-to-speech, even videos.
And then there's more ambitious applications like
Yeah, like we talked about latent multimodal reasoning, world modeling.
embodied AI. It could be everywhere.
Yeah, it really could.
One of the things that excites me most
Yeah.
is the potential to bridge the gap between, you know, the real world and the digital world.
What do you mean?
Well, think about how we interact with computers now,
Yeah.
right?
Keyboards, screens, microphones.
Yeah, it's very limited, very indirect.
Right.
But what if AI could understand our world the way we do?
You mean like through our senses?
Yeah, sight, sound, touch, maybe even smell, taste.
So instead of typing a search, we could show the AI a picture,
Exactly, or a video of something we want to learn.
and it could respond in the real world, not just on a screen.
That's the idea. We could have robots that understand us, AI assistants that can anticipate our needs.
It's almost like science fiction.
It does feel that way, but it's getting closer.
It really is.
And this raises all sorts of questions.
Yeah, about how we'll interact with AI in the future.
Right, it's exciting, but we also need to be responsible.
Absolutely. Any technology can be misused.
We need to think carefully about how we develop and use these AI systems.
Yeah, make sure they're used ethically for good.
That's a good point to emphasize.
I think so too. I mean, LatentLM is a remarkable technology, but it's up to us to use it wisely.
Couldn't agree more. It's been great diving into this topic.
Yeah, me too. Thanks for joining us.
My pleasure.
And we'll be back next time with another look at the cutting edge.
Looking forward to it.
Until then, keep exploring, everyone.